In this video, you will learn how to dynamically calculate a cumulative value that is dependent on previous values in a list, and we will do it in linear time. Hello and welcome to the Python implementation of LeetCode problem 1137, nth Tribonacci number. The problem states, the Tribonacci sequence T of n is defined as follows. T of 0 is 0, T of 1 is 1, T of 2 is 1, and T of n plus 3 is equal to the last three in the sequence, T of n plus T of n plus 1 plus T of n plus 2 for all n greater than or equal to 0. Given n, return the value T of n. For example, example 1. Input n is 4. Output is 4. Example 2. Input n is 25. Output is 1,389,537. The constraints are n is an integer between 0 and 37. The answer is guaranteed to fit within a 32-bit integer. What this is really asking is, we have a target number and we want to calculate a value from that number. But that output is part of a sequence, so we must know all the values that come before in the sequence in order to calculate the final output. We want a way to calculate this number without recursion or nested loops. This is a dynamic programming problem. We can guess that because it does not work on a list, graph, or range. It does not find a target value, minimum, or maximum. It has small bounds, and it has an inefficient iterative solution. You might find this type of problem in other fields, including population growth, for example, a species where individuals become fertile in their third year and live exactly 3 years. So the number of births in this year comes from the cohorts aged 1, 2, and 3 last year. Finance and accounting. For example, rolling 3-month net cash is equal to the inflow of month n minus 1 plus month n minus 2 plus month n minus 3, also known as an accountant's quick KPI, or manufacturing and supply chain. For example, a work cell whose throughput today equals parts released from the free upstream cells finished 1, 2, and 3 shifts ago. For example, curing, cooling, inspection each shift. If you're serious about acing coding interviews, I've got something that will help. Sign up for the LeetKey newsletter and get weekly LeetCode problems, detailed solutions, and proven strategies delivered straight to your inbox. Now back to the video. You might be inclined to solve this by using recursion to calculate the value for n by adding to its previous value in a loop, and by doing that for each of the triplets to get the final value. But this approach ends up looping over n for each number in the triplet. Alternately, you might fill an array with values, one for each Tribonacci number, but that results in a lot of extra space used. A more optimal solution is to keep track of the last 3 values of the sequence and to add the values to update the sequence as we count up to the final value at n, which we return as our output. This provides both linear time complexity and static space complexity. Let's see how to implement this solution. This solution keeps a running tab of the triplet values as it iterates over a range. First, we define the initial values for inputs 0, 1, and 2. We return the pre-calculated values if n is 0, 1, or 2. Otherwise, we iterate from the base cases to n, calculating the sequence output at each step. At each step, we calculate the current value from the last 3 in the sequence. Then, shift the new value across the last 3 values. We do this in a loop until we reach the nth step in the sequence. At the end of each loop, the most recent calculation holds the nth Tribonacci. The space complexity for this implementation is static, since we don't create data in proportion to any loops. The time complexity for this implementation is linear, since we iterate up to n once without any additional loops. That was how to solve LeetCode problem 1137, nth Tribonacci number. Thank you, Tim, for subscribing. Next week, we will be looking at problem 746, min-cost climbing stairs. So, subscribe and click that bell to get notified when that drops. And let us know in the comments which problems you'd like to see next. Please share this video with any programmers or aspiring coders you know would benefit from its insights. It's word-of-mouth referrals like yours that really help this channel grow. You can get this video a few days earlier, plus other exclusive content on our Patreon.